for secant of 3 theta plus 6 equals negative 2. All right, same instructions. I want to find the general solutions, and then for part B, the solutions inside of 0, 2 pi. 0, 2 pi is just a very common interval to solve for. The book asks you to do 0 to 2 pi, but when you get to Cal 1, this interval could be anything. It could be 0 to pi, 0 to 2 pi, it could be negative pi to pi, it could be negative 2 pi to 2 pi, really anything. So you know how we've been starting with k as 0, then 1, then 2? It's possible in Cal 1 that you actually have to go negative with your k's as well. So k negative 1, k negative 2, k negative 3, and get some negative angles in there as well. I'm not going to torture you like that until you get to Cal 1. But for here, we'll just stick with 0, 2 pi. All right. Secant is the reciprocal of cosine, isn't it? So what I'm going to do is I'm going to try and solve this. I'm going to try and get secant theta by itself. Try and get that by itself first. So to get that by itself, I'm going to move this to the other side, right? So I subtract, yeah, wait a minute, what the hell? Yeah, this is going to work. Right, so this becomes 4 secant of 3 theta equals negative 8, right? Just subtract 6 on both sides. Divide both sides by 4. Secant of 3 theta equals negative 2. Go with me? Secant of 3 theta equals negative 2 is the same as saying cosine of 3 theta is what? Negative 1/2. Good. Right? Secant of 3 theta being negative 2 is the same as saying that the reciprocal of this function is the reciprocal of that. The reciprocal of secant is cosine. Now, that says to look at the unit circle, look at which coordinate? The x coordinate, and tell me where it's negative 1/2. Where is that? There, right? And there. Shit, they're not directly across from each other. So we can't jump around like we did before. We're going to have to do 2 sets of general solutions. All right. Who wants to volunteer my first set? Go ahead. What do you got? So this one right here, you're going to say that's 2 pi over 3 plus 2 pi k. Good. Who wants the next set? That's this angle. How about this one right here? Who wants that one? Go ahead. 4 pi over 3 plus 2 pi k, right? That's a visual representation of all of those angles, all infinitely many, right? All right, who's going to tell me the 2 equations I'm going to write down now? Who wants to give me the first equation? Because this is just the angles, right? What's the first equation I need to solve? I'm not ready for common denominator yet. What needs to be equal to this, and what needs to be equal to this? The 3 theta needs to be equal to this, and the 3 theta needs to be equal to this, right? Don't lose sight of that. We have to set the argument equal to these general representations of our answers. So I'm going to write down, what was the first one you want me to write down? What? Someone? What? 3 theta equals that first one, right? 2 pi over 3 plus 2 pi k. And then the other one is 3 theta equals the other general solution, 4 pi over 3 plus 2 pi k. Please don't forget that part. That's a big mistake I'll see students do. is they do all this great, and then right here they say theta must be this or theta must be this. No, not quite. 3 theta has to be that, or 3 theta has to be that. And then you solve for theta. So divide everything by 3. What do we get here if we divide by 3? Theta equals 2 pi over 9, right? Divide both by 3. Plus 2 pi k over 3. And then over here, same thing. Theta equals 4 pi over 9 plus 2 pi k over 3. And now you can do your common denominator. Okay? What's our common denominator? 9. So I'd probably multiply this one by 3 over 3 and then do this one over here by 3 over 3. Let me go ahead and put those over here. So I have theta must be, let's see, 2 pi plus, what is this? What is this going to become here? We do 2 pi plus, then this is going to be 6 pi k. 6 pi k, all of that over 9. And then the other general solution would be 4 pi plus, again, 6 pi k. All of this over 9. Those are your 2 sets of general solutions. So that takes care of part A, right? This would be part A's answer. And how do we do part B? Start plugging in values of k, okay? It's going to suck. Let's do it, though. If k is 0, let's see what we get. Does anyone have a question up to this point, though? You all are all right? All right, so if k is 0, that's what? 2 pi over 9, right? So 2 pi over 9 is one answer. And then let's get this one also. If we do that, 4 pi over 9. We're not even close to being past 2 pi yet, right? Maybe I can make a guess. I don't know. I would have to get past 2 pi, I would need an 18 up here, right? So how big does that have to be? 2 and 3. I think 3 is going to, I think we're going to have to do k equals 1 and 2, but I think once we get to 3, we'll be outside. So k is 1. Let's see, the top one, if k is 1, we get 8 pi over 9. If k is 1 here, we get 10 pi over 9. If k is 2, up there we get 12, 13, 14 pi over 9. And then here, 2, 12, 16 pi over 9. And I think on the next one, it gets too big, right? Does it? K is 3. 6 times 3 is 18, plus 2 is 20, so we're going to be at 20 pi over 9. And 20 divided by 9 is bigger than 2. So we're too big there. And this one is bigger than the other one, so that one's not going to work as well. So we have, what, 6 answers? Those are our 6 solutions. In this interval between there and there. Are you ready? 2 sine squared theta minus sine theta minus 1, or we want to do plus 1? Let's do minus 1. minus 1 equals 0. All right, this is a shift. This is a different type of equation now. This is different than what we've had up to this point. Up to this point, I've been able to get like cosine of something equal to a number or secant equal to a number, but I've just had one trig expression, right? Here, we've got a sine squared theta and a sine theta, don't we? There's 3 terms in this problem. What does this look a lot like? If you squint your eyes, it looks like a quadratic, doesn't it, kind of? Like just imagine I asked you to do this. If I said, let u make a substitution, replace all of your sine thetas with u, what would this equation look like? 2u squared minus u minus 1 equals 0, right? That's what that would look like? And to solve a quadratic equation like this, you could either factor or you could use a quadratic formula, right? Now, this, I hope, being pre-cal students, and taking us back to the very beginning, partial fraction decomposition, we had to factor back then, didn't we? We should be able to factor this. 2u, u minus 1 plus 1, I believe is what we've got here. I should have put here solve, okay? Solve this equation. So are y'all okay with this factoring? Let's just check it. 2u squared minus 2u plus u minus 1. Now, if we put all that together, we get that. So do y'all buy that as far as the factoring? Yeah? Any questions on that? Y'all are looking at me like you're upset with me for some reason. Something I've done. It's all my fault, right? All right, when you factor a quadratic, you can set each factor equal to 0, can't you? All right, so let's continue down this road. This means 2u plus 1 must be 0, and we have another equation that says that u minus 1 must be 0. Can you solve these for u? Oh, just like a little thread just came out of nowhere. All right. This one, what's the solution for u? Negative a half, right? And over here, u is 1, right? So, had this been this, right? Had this equation been this, those would be our 2 solutions, right? But we made a substitution. We said u is sine theta, right? So let's go back and replace u now with sine theta. So this says sine theta is a half. Negative a half, sorry. And this says sine theta is 1. Right? Now, each of these, let's look at these as 2 separate problems now. If I gave you this, what am I really asking for you to look at there? Where's the y coordinate negative a half on your unit circle? Where's your y coordinate negative half? So where is it? Negative half, right? So over there, right? And right there. Those 2 angles right there. And this one is saying, where is your y coordinate what? 1, which is straight up, right? Now, I asked you to solve this, right? And I didn't tell you on an interval. So that means I want all the answers, the general solution. So for this, can you be cute and like jump from one to the other or not? No. So you're going to have to give me 2 sets of general answers here. And this one, there is only one answer, general answer, right? You're just going to go there and then just go all the way back around, all the way back around, all the way back around. So maybe I start with this one. This one's easier. Who wants to give me this answer? Someone who has not responded today. And give me the solutions here. Pi over 2. So theta equals, right? I can say theta equals, who's talking? Okay, there we go. I can say theta because the original argument was theta, right? So theta equals what? Pi over 2 plus 2 pi k. There we go. Do you need to get a common denominator there? No, because I'm not asking you for answers between something, so you're not going to have to cycle through k's. You just need to make sure you have that answer there, right? All right. How about over here? Who wants to give me one of the general solutions here? Someone new.
Pi over 6 plus 2 pi k.
So thank you. Theta equals 7 pi over 6 plus 2 pi k. That's that one, right? And then the other one over there, I think that's 11 pi over 6, isn't it?
Yes.
Could you say negative pi over 6?
Yes.
Yes, you could go negative pi over 6, or you go all the way around. It doesn't matter because you're going to be adding 2 pi k, so it doesn't matter where you start from. So theta equals, I'll go with the 11 pi over 6 plus 2 pi k. There we go. The infinite number of solutions to this equation are all those angles of these forms. You can start letting k be 1, 2, 3, 4, negative 1, negative 2, negative 3. We have an infinite number of answers. But I promise you that if you pick a k, plug it in here, give me that answer. If I plug that in here for theta, I'm going to get this solution to be true. Do you want to check an answer or no? Yeah? Okay, we'll check one. How about, let me just check this, 11 pi over 6. Let's just see if that's a solution to this equation. I'm going to replace all my thetas with 11 pi over 6. So I'd have 2 sine of 11 pi over 6 squared minus sine of 11 pi over 6 minus 1 equals 0. And the question is that true? Right? Is that true? So I need to know what sine of 11 pi over 6 is. And don't we already know what that is? 11 pi over 6, sine is the y-coordinate, so it's negative a half, isn't it? So if I replace this 2 times, this becomes negative 1/2. But remember, I have to square that answer, so squared, minus sine of 11 pi over 6, which is negative a half. And then I have minus 1. This should be 0. I don't know yet. What's negative a half squared? So what's negative times negative? Positive, right? Half times a half is a fourth. So this is 2 times 1/4. Minus minus is plus. Plus a half minus 1 equals 0. What's this? 2 over 4 is a half, plus a half, minus 1 equals 0. A half plus a half is 1. 1 minus 1 is 0. Checks. That's one of the infinite number of solutions to this equation. I wouldn't describe the looks on your face as thrilled. Next one. Solve sine of theta equals 0.40. A, general solution. B, on the interval 0, 2 pi. All right, this problem is different because the equation is actually pretty straightforward. This is saying where's the y-coordinate 0.4, right? Problem is 0.4 is not something you recognize. Do you agree? But I do know that what it's asking me for is the angle that would give me a y-coordinate of 0.4. So some angle here, I know there that the y-coordinate is 0.4. Is that the only place where the y-coordinate would be 0.4? Over in the second quadrant somewhere, right? This y-coordinate would be 0.4 as well? So there's two different places, aren't there? Two different places where this could happen. The problem is, again, it's not one of my common angles. I don't know what this is, right? If I knew what it is, and I would just tell you, like pi over 3 plus 2 pi k or something like that. But I don't know what it is. And I sure as hell, if I don't know that, I don't know that. So how do you think we can get this angle? How do you think we can get that? This, right? So in your problems for your homework, it'll tell you on this, solve this, use your calculator, all right? So I want to know when sine of some angle is 0.4. So that really means on my calculator, I'm going to do sine inverse of 0.4. And let's do this in degrees, all right? Let's do this in degrees first. So what is sine inverse 0.4? 23.6, yeah? 23.6 degrees? Approximately. Well, that's this angle, right? This angle I didn't know? That's 23.6 degrees. That's that one. But I'm missing an angle, right? What angle am I missing? The one over here, right? This calculator is only looking between pi over 2 and negative pi over 2 because that's the restriction on this trig function, or the inverse trig function. But I know to solve this equation, there's no restrictions here, right? I have no restrictions on my domain here. I only have restrictions on my domain because I want to use my calculator to help me. I actually do need this answer. So this is what I started this whole thing with. If you knew that angle, can you tell me that angle now? What would it be? You do the 180, right? And you take away the 23.6. And what's that? I don't know, whatever it is, right? Minus 23.6, make sure, 156.4? All right, I'm ready to give you my answers. I'm asking for the general solutions first. So that means I need to be at this point, and I need to go all the way back around, right? All the way back around, all the way back around. We've been doing 2 pi k, haven't we? 2 pi k, 2 pi k, every time we want to go all the way around. But do you see that my first answer is in degrees? So to go all the way around, I don't want to use 2 pi k, I want to use 360 k. So watch the way I write this. First time I think I've done this in here. I'm going to say theta equals, this theta, this angle, needs to be equal to that angle, 23.6 degrees, plus full rotations. So instead of 2 pi, I'm putting 360. And then k, because I still need to just do arbitrarily, however many rotations that I want. That's one of the general solutions. The other one is this angle, add the full rotations again. So 156.4 degrees plus 360 degrees times k. Those are your general solutions. Questions there? Now, if we want the answers between 0 and 2 pi, we really want the answers between 0 and 360, don't we? And I believe if you look at this, if k is 0, those are two answers, right? If k is 1, we're already past 360 on both of these. Right? If k is 1, that's bigger than 360. If k is 1, that's bigger than 360. So we only have two answers. It's these two. So our general solution is what you see boxed up. The answer to part B is just those two angles, 23.6 degrees and 156.4 degrees. I'd like in the last 8 minutes, I want you to work together in groups or teams or whatever. I want to see if you can give me the general solution to this equation. The general solution. Four cosine squared of 6 theta minus 3 equals 0. Let's do this on a separate piece of paper. And let's put your name on it. And let's work together and get this thing, general solutions only. That's all I want, general solutions. And let's turn it in before you leave today. While you're doing that, pardon me? No, I didn't say that. What if I say it's bonus? That makes you feel better, right? It's something, all right? While you're doing that, I'm going to put what homework I want you to do tonight up on the board. I want the same as what we did last time for this homework. I want to see it on paper and pencil when you come next class. On the ebook, page 647. Help each other out. You can talk. There's nothing wrong with talking. If you want, I can come by if you have any questions while you're doing this. You only have a few more minutes. You have 5 minutes. Yes.
So, bracket point.
Mm-hmm.
We would have to square?
Square root both sides of the equation. And whenever you do that, remember you always have to do, when you take the square root on both sides of an equation, you always have to do, no, not flip. No? Plus or minus?
Yes.
Plus or minus? Plus or minus? Okay, so the left side, the squared goes away, right? And you just get cosine 6 theta. And then careful, you're doing square root, not squaring it. You're taking the square root of 3 over 4. Do them separately. Square root 3 over, no, you're good. Square root of 3 over square root of 4. Do them as separate. Do a square root on top and bottom separately. And I think you'll recognize it if you do it that way.
I mean, 2.
What are y'all doing?
We're trying to figure out how
Good.
to solve for that. Oh, yeah?
Plus or minus, though. When you take square root, you have to do
okay.
plus or minus. Yeah, good. Plus or minus. Remember when you take square root, plus or minus.
Yeah.
Are y'all doing okay or what?
I don't know. Let's check.
Yeah, good. Okay, perfect. So do you know what that's asking you now? Thinking unit circle here. That's asking you what? Mm-hmm. When what? When what's what? Cosine's what though on the unit circle? So you want to know when the x is what?
Positive or negative root 3 over 2.
Positive or negative root 3 over 2. You recognize these? So the x coordinate, where's that? Well, y'all figure it out. How many places are there though? There's 4. There's 4 places. I'll be over there. Yeah, plus or minus. When you take square root, do plus or minus. All right, you got something? Plus or minus. Remember when you take square root, you have to do plus or minus. So you're actually going to have 4 different places this happens. Right? Because you'll have the pi over 6, the negative pi over 6, but then also here and here as well. Know what I'm saying? When you take the square root on both sides, when you do that, you have to do plus or minus. Okay? Okay, y'all were on? I'll go over here yet. Yeah? Okay, good. Just remember when you do the square root on both sides, you have to do plus or minus. Is that what y'all did as well? Yeah, plus or minus. So look, when you do that part, when you're on the right side and you're doing this, that's the same as square root plus or minus square root of 3 over square root of 4, which is plus or minus square root of 3 over 2. I didn't see that on there, but right, isn't that the same? And do you recognize that? I think most of y'all have this. I didn't check over here. Were y'all getting there?
We're good.
Did you got it? Plus or minus?
Yeah.
Okay, good. All right, I'm just going to work through this real quick. I think most of y'all got to this point right here, where you do the square root on both sides. Remember that if you ever take the square root, you have to do plus or minus. And so this is asking, where on the unit circle is your x coordinate positive or negative root 3 over 2? And you have to know, did I tell y'all how important it is to understand the unit circle? Have I talked to you about that here? Obviously, right? I mean, it wasn't lying. It's because you need it, like, right? It's like crawling. You have to crawl before you walk. Like, so that's here, 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 and here. At those 4 points,